Okay, so if you remember, in the last class we were discussing about the dynamic memory management operators in C++, and Professor PPD summarized it as, there are three sort of broad steps, you can say, uh, in the way the new the new operator or the array new operator operates. Okay, first step is that once you give an input of a type, okay, in case of new operator, and in case of array new operator, you give input of a type and the size of the array to be allocated. Okay, uh, these operators, they compute the amount of memory that is needed. Okay, then in the second step, so this is the first step. Okay, in the second step, actually the actual memory allocation is done. Okay, and that can be done, so we will come to that. Okay, and in the last step, uh, there is a object creation that is done. Okay, and so for example, we haven't so we will today we will go into classes, but so essentially, object creation can have many steps. So for classes, it involves calling the constructor. Okay, for the normal data types, it may involve simple things like changing the return pointer type to the appropriate type, which is the input type. Okay, and also initializing the object. Okay, so these are the two things that you can you can do for the built-in data type. Okay, now yeah, now this operator new actually operates in the second stage, as was discussed in the last class, that the operator new is the operator function corresponding to the new operator. But unlike other operators, the operator new function only gives you control over the second stage. And the reason for that is also mentioned, that the first and the last stage require that you pass the type as an argument, which is currently not allowed in C++. Okay, so so only the memory allocation part is what is under your control in this operator new function, or this operator array new function. Okay, okay, and there is a placement new function also, and that has its own operator also. But okay, so, and as we discussed, there is no corresponding delete operator. Okay, so yeah, so if you pass null pointer to the delete operator, okay, in by default, okay, then it is secure. Okay, so that is another thing that for example, that if you pass a null pointer to the free, so before passing it to free, you should really check, because it can lead to unexpected result, but that is not the case with delete. Okay.
Sir,
Yes.
sir, I had a question from previous class.
Yes.
Sir, suppose that I have some objects of a class such that there are few of them I do not want to call the destructor, but for the others I want to. So in that case, can I use free along with the new operate new?
Uh, no, you cannot. Right? Like I mentioned, you cannot. So this was discussed in the last class. So see, malloc and free are not the default memory allocators for the new operator. Okay, so it's operator new. Okay, It's so if you call, so it's like, so in your mind, so this is not exactly correct, but in your mind you can think like this, that malloc and free operate on different memory. Operator new and operator delete, which are the C++ version of malloc and free, okay, these operate on a different memory. Does that clarify?
Okay, sir. Okay.
So you should never mix and match. So this is the first thing that they tell you. Okay. So now, okay, yeah. So yeah, so new operator allocates the exact amount of memory from heap and returns. Okay, yeah, it returns the given pointer type. Okay, and yeah, new and array new and delete and array delete have separate semantics. Okay, so now you see that just like in operator overloading, you can also overload the operator new function for the new operator. Okay, but as we discussed, the new operator is special, or the operator new function for the new operator is special in the sense that there is a pre-processing and a post-processing that goes on. Okay. Okay, so how will you overload the operator new? Okay, operator new function. So the middle step or the second step of the new operator. Okay, so here is the syntax for that. Okay, so you return your return type for operator new is void star. This we discussed in the last class, that even though new returns the input type, the operator function for new still returns void star, just like malloc. Okay, and it takes as input the size of the memory to be allocated, and it is of type size t, which is defined in stdlib. Okay, so this is basically an unsigned int type. Okay, okay, so okay, so you can write your own code inside here. Okay,
Sir, what is size underscore t?
so this is a defined type, which is basically of unsigned int type. Clear?
So can we take int also?
No, unsigned int. Okay,
We also
because
can take unsigned int.
size cannot be negative. Okay.
But sir, in the int we can store positive value.
Yes, but if it overshoots, then it can become negative. So the type is unsigned int. It can only store 0 or positive values.
Okay, sir.
So whatever representation you give as input, it will only be interpreted as positive. So it's an unsigned int type. Okay. So okay. So yeah. So okay. So this is one thing, and here we have just demonstrated what we were telling in the last class, that you can simply use the malloc as the memory allocator for new. So this is what this particular overload is doing. So it is using the malloc. Okay, and this is how you overload the operator delete. Okay, so it again takes a pointer of type void star. Okay, and it's of type void. So the delete operator cannot return anything. Okay, and in this particular case, you can do whatever you want to do within the delete operator. And then in this case, because in new we have used malloc as the memory allocator, here we have to use free. Clear? So in this case, new is actually using malloc to create the memory, but new is also doing other things. The new operator, that is doing some more things, and similarly for delete. Okay. So this is the program where you create a new int, okay? And in this case, it is calling the overloaded new operator, okay? And it is basically creating space for one integer in the heap managed by malloc, okay? And yeah, and then you can assign it to anything, and then you can just say that delete p, and that will again call the delete operator. And you can see here the output, okay? So first it prints overloaded new, okay? Then it of course prints the value, and then when delete is called, it actually prints the overloaded delete message, okay? So that's confirming that, you know, indeed the overloaded operator has been called. Okay, so yes.
Sir, in delete the parameter is void star, but from main we are not doing any type conversion. So does it happen automatically by the compiler?
Yes, right. That's what. So okay. So we have discussed about new, about delete also, right? So the delete operator also, not the delete operator function, which is operator delete. The delete operator will take as input the pointer to the memory, okay? And its type type can be anything, okay? So like we said, so the delete operator will obviously convert it to void star type and pass to the actual the delete operator function, which is operator space delete, okay? And so this function will work, okay? So now actually, yeah, okay. So we will come to array delete in a minute. So so sometimes so for example, the delete operator can also do other checks, right? If the input is, for example, null, it will not even call the free, okay, or call the operator delete. So it can do such checks also.
Okay, sir.
Okay, so okay, so and this is a program, so where we are demonstrating two things. One is we are overloading the array new operator. Okay, so so two things which is different in case of array new operator. First, you can see that it is also taking a size as the input. Okay, so here also, since remember that this is the memory allocator function, okay, so it is calculating the entire size, okay. So remember, to the array new operator, the inputs were two. One was the type of the object to be created, okay, and the other was number of objects to be created. But to this input, there is only one size, okay. And this size is basically the total memory required for total memory to be allocated, okay. So this is one. So this is one part, okay. Now another thing we see here is that it is taking another argument in the new, okay, and so this argument is of type char, okay. And then what we are doing is we are calling the operator function of the new operator. So we are not using in this case the malloc anymore. So we could have used malloc also. We are using the operator new function to allocate a memory. So we are giving it the size OS and getting the void star type as output. Okay. Then what we are doing, we are using this memset function to actually copy this input value, input character, which is set v, okay, to this particular address, okay. So so memset basically takes three arguments. First is the address where it needs to be copied. Second is the character or the byte that needs to be copied, and third is the number of bytes where this particular character needs to be copied. Okay, so that is what memset is doing here. Okay, and then again we are returning t, which is still of void start type. Okay, and the new wrapper will do the rest of the job. Okay, okay, now you see we are using this overloaded new operator to actually allocate characters. Okay, so we are allocating 10 characters. Okay, and each character is of 1 byte. So basically, this OS will be 10. Okay, and the other thing that we see is now this second parameter that we pass to new operator is available to, you have to provide it to the new, and this is how you provide it. Okay, so this is different from providing input argument to the type, okay, which is after the type you put, right? So you could also put within brackets you could put some arguments here. Okay, for example, for initialization you can put that. Okay, so we will come to that, but yeah, so this is basically, so hash is being copied to this variable setv, and which in turn is copied to this thing. So what you can see here is that right after this initialization there has been no assignment, but when we are printing this t, okay, okay, so what is happening is it's basically printing hashes, which means that t right after this already contains the hash characters in all the 10 location. Okay, so I hope this is clear, right? So you can do this argument passing to the new operator also, by the way. Okay, so not just the array new, to the new operator function also you can do argument passing, and you can use that argument. But argument passing is not allowed in the delete operator. Okay, so and yeah, and so as you can understand, because you are allowed to pass more arguments, basically you can do more and more overloads of the new operator. So this new within bracket character is one overload of the new operator. You can pass an int, okay, to create integer overload of the new operator, and so on and so forth.
Sir, if we don't pass any type of argument in the operator new, so then will it call the previous operator new, which was predefined in the C++?
Yes, right. So it will call for the operator function. It will use the standard operator function for the new. Like we discussed, there are 3 stages. There's a processing stage which is before this operator function gets called, and there's a processing stage after the operator gets called. So for the middle portion, it will call the standard array new operator function. Is that clear?
Yes, sir.
Okay.
Sir?
Yes.
So suppose in the operator delete, instead of void star ss, if we are to pass it as char star ss, then it would still work in this case, right, sir?
No, it will give an error.
So, but in this case, t is a char star only, right? So it should work, right?
No, but the formal argument for the delete operator function is void star, right? And C++ does strict type checking. So you have to cast it and pass.
Okay, sir.
Okay, so okay, so I think yeah, so that concludes the dynamic memory management part of our discussion. So any questions or comments? Okay, so in that case, Okay. We now go into possibly the most important part of C++, which is classes and objects. Okay. Okay. So I think most of you know this. So let us go quickly. If you have any questions, we can just discuss. Okay. So as you all know, a class is an implementation of a type. Okay. In C++, structure is also, so by structure, I mean struct keyword, the structure that you defined using the struct keyword, that also implements a type. Okay. But it is not a full-fledged user-defined data type. Okay. Or UDT, which is a concept. Okay. Which is that it should, yeah. So it should behave exactly as a standard type. Okay. So it should have, what are the concepts in a user-defined data type? Okay. So basically, as given by class, for example, it should have the following feature, which also the class provides. Okay. And the features are basically it should have data members or attributes. Okay. Which, struct also provides. Okay. It should have its own operations or member functions or methods. Okay. Which struct does not provide. Okay. Class also defines a namespace. Again, something, yeah. So it's a little bit tricky. So, but in case of class, it definitely defines a namespace. Okay. Okay. So overall, what you can say is that classes offer two things. First is data abstraction. So, you can abstract out a particular data in a class, okay, or in an object of a class, okay, which we will come to. Okay. So you can do that in your program using this feature called class. Okay. You cannot do it with any other feature. Okay. And also encapsulation. So encapsulation is basically the data aggregation and data protection, and data abstraction is from the user's point of view, that the user of a particular class can think of the class as an abstract user defined data type and use it in his or her programs. Okay. So so it provides encapsulation from the point of view of the programmer who is defining the class, and it provides data abstraction from the point of view of the programmer who is using the class. Okay. Okay. So classes are similar to structures. Okay. Class is defined by the class keyword. Okay. And classes provide access specifier for members, both data members and member functions. Okay. To enforce what is called data hiding. So data aggregation is one part of the encapsulation, but data aggregation itself. So here the concept of encapsulation is that it's like a protection. Okay. So you can think of the data as the data of a class or the information content of a class as something that needs to be protected. Okay. So from that point of view, it should be kept together. Okay. So that part is provided by structure also, but the access specifier portion of the data protection or encapsulation is not provided by structure. Okay. Okay. So yeah. So as we shall see, this leads to separation of implementation and interface in programs. Okay. So it uses two keywords, private and public, to actually provide this access. So these are the access specifiers which which will provide you the data hiding principle. Okay. And the important thing to understand is that a class is a blueprint for its instances, which are called object. Okay, so class is it's like a blueprint. It's like a if you see a building, okay, you can create blueprint of a building. You can create many buildings of same type using a particular blueprint. Okay, exactly the same plan, same way to construct the building and so on and so forth. So it is something like that. You can create many objects or instances of a class. All of them will follow only one blueprint. Okay, so you cannot redefine a class, but you can create many instances of a class. Okay, so this is about classes. Objects, like we discussed, an object is an instance of a class created according to its blueprint. Objects can be created automatically, statically, or dynamically. Okay, so automatically is on a so it's like any other variable that you create. Okay, so basically automatic means that it's created automatically on the stack and managed automatically. Okay, static means that it's created in the beginning of the program and persists through the entire program. And dynamically is using new or something like that. Okay, so which is created and managed by the programmer. Okay, so an object comprises of data members that specify its state. Okay, so that is important, that the data members of an object specify its state, and basically so long as the object is there in memory, the data members hold their value for a particular object. Okay, for a different object it will have different values. Okay, same data member of the same for a different object of the same class will have different value. That is how two different objects will basically store different information. So they will they will denote different things. Okay, the other thing is that an object also supports member functions that specify its behavior. Okay, so basically the member functions of an object, so they sort of, we will see this in somewhat greater detail. So they basically specify how the object interacts with the rest of the program. Okay, and also what are the things that can be done inside the object itself. Okay, so these are the two things. Okay, so we will see in greater detail. Okay, yeah, so okay, so the data members of the object are accessed by the dot operator. Okay, and member functions are also invoked by the dot operator. Okay, importantly, there is an implicit this pointer. Okay, so you may not define and you cannot define actually this pointer in the blueprint of the class. Okay, so when you are defining the class, there is no this pointer that is defined, but it is implicitly present in every object. Okay, and it holds the address of that particular object. Okay, so the memory location of that particular object, and whatever memory layout the object uses, that is up to the compiler, of course. Yeah, but basically this pointer will always point to a particular memory location, which is also the location of the object, and importantly it is also the identity of this particular object. Okay, so so this is another important thing, that how do you know two objects are same? Basically these pointers should be same. Okay, so yeah. Okay, okay, and yeah, so this pointer is implicitly passed to the methods. Methods means member functions. Okay, So that is the important thing, that you cannot, so this pointer is not available in non-member functions. Okay, so so this is the other thing, that you can you can try to pass it to non-member functions, but by default this pointer is not available. It's only available to the methods. Okay. Okay. So here are some programs. So I think you can very easily understand. Okay. So left side is what we are. So we are trying to create sort of a user-defined data type, which sort of stores a complex number. Okay. So left hand side is how you would do it in C. You will create a structure. You will store the real component and the imaginary component. Okay, and then you can do print and everything. Okay. The right hand side is one way, a preliminary way of doing it using class. Okay, so you can see that we are using this class keyword here. Okay, and then we are defining the data type complex. Okay, and then we are saying that all data is public. So this is how you say it. You say public colon, and then after that, whatever follows is public. Okay. And then you are defining two doubles, real and imaginary again. Okay. And you are not defining any member functions here. Okay. Now you can just.
Sir, can we initialize like this? 4.2, 5.3.
Yes, you can, right? So just like you can initialize structures, you can also initialize classes like this. There are other ways of initialization which are more preferred, okay, which we will discuss using constructors. But in this case, you can just do this. Okay.
Okay, sir.
Okay. Okay. So now, and then you can print. Okay. So yeah. So class is a new keyword in C++. Okay. So you can see that basically you are defining a type complex, and then you are saying complex n1 equal to something, and it is creating the complex object here. Okay. Yeah, and the data members are accessed with the dot operator, which is n1.re, and so on and so forth. So I think this part is clear. So let us go ahead. Yes.
So what was that public doing there? Means what is assigned as public?
So these, so both RE and IM are public, which means, see, this main function is not a member function of complex, right? But you can still access this as n1.re. Clear? So if this was not public, you wouldn't be able to do this operation in main.
So sir, the variables are public, right?
The variables are public, right? Yeah.
Okay.
Because in this case, there is nothing else. Yeah. So we will see. We will go into detail of that. Okay. So this is again another example of we are trying to create a rectangle. Okay. So again, on the left is the C code. We are not. You can see we are first defining like one type point, and then we are defining another type rect. So point is basically a two-dimensional point with x and y coordinates. Okay, and then rect is the two two ends of a rectangle, which is the top left and the bottom right. Okay, and the same thing can be done here in C++ using class. Okay, and again the same thing can be initialized like this, as you can see here. Okay. Okay. And then what you can do is you can simply print each of these also. Okay. So I hope this is clear. Yeah. Okay. Okay. So now again we are showing another thing, which is a stack. Okay. Again, you see So this example, what this gives you is gives you an idea how you can now, organize your program in a object-oriented fashion, right? So so this is a very small program, but you can still see, right? So there can be objects of type point, okay, which are types of objects. And then you can use that type to define more types. For example, a rectangle. Rectangle is another type of object which you are defining by this class. Okay. And like this, you can now keep on composing different types of objects to define more and more complex types of objects. So this is a facility. This is sort of how you build object-oriented programs. Okay, there are other facilities we will see. Okay, here again you see stack is again something, it's a entity that you visualize, and you want all the related data of the stack to be together. Okay, and this is what is happening here. So stack should have some space to store the data of the stack. So it's a character stack. Okay, so we are having a character array of size 100, and we should also store the top pointer. Okay, so it's the top is of type int here. Okay. Okay, so and then here you can when you say stack S here, you see both the component data types are declared, and you can assign like this. Okay, yeah, so you can basically have mixed type of data. Yeah, so I think these are sort of pretty clear to everyone. Okay, yeah, so yes.
Sir, if in the previous slide, if the class is initialized like stack S, then what are the member variables assigned? How are they assigned?
Okay. So you have to initialize then the data and the top and the data. So you will have to, the usual, C++ initializer. So you within parentheses, you have to first give the initializer for the data, and then comma, and then the initializer for the integer, right? Yeah. And you know how to initialize arrays, right? So again, within parentheses, you can just provide the elements of the array.
So sir, how was top, if I do not assign s.top equal to -1, what would be the value if I just print it?
Oh, no value, no initialization here. Oh, okay, yeah. Okay, so you don't know, it will have a junk, it will have garbage value. So just even right now, all the 100 characters in data will have junk value. Right?
Okay.
Okay, so we will come to initialization. Okay.
Sir,
Okay.
isn't any constructor definable here?
We will come to constructors in a minute. Just hold on. So maybe not today. We will have some constructors today also, maybe. Okay. Okay. So I think this part is clear now. Okay. So by the way, for this one, there is no constructor defined. Okay. So so let me clarify that. Okay. There is a default constructor. So if you don't define a constructor, okay, there is a default constructor that the compiler defines for you. Okay, and there is also a default destructor, by the way. Okay, and the default constructor simply allocates the memory, okay, of the members. Clear? So I think sorry, I hope
yes,
that
sir.
Last question. Yeah, so in this case, the default constructor will simply allocate the memory for data and top. Okay, so it will have a certain memory layout. Yeah, clear. Okay, so now yeah, so this is just a recall of whatever we did. whatever we discussed. So yeah, so a class can implement user defined type. You saw how. Okay, it contains members, attributes, defines a namespace. So we will see this part a little bit better. Okay, yeah. Okay, so I think all these parts are clear, and we also know what is an object. So in this particular case, just to be clear, this part is the class, okay, and S is the object, and you can define more objects of type stack. Okay, so you can define S1, S2, and so on and so forth. You can even define arrays and so on and so forth. Okay, in this program, again, you see this is very interesting. Okay, so just to connect to the object here. Okay, see, when you are defining rectangle, what you are doing is you are actually saying that rectangle contains two objects of type point. You see this? So TL and TL and BR are objects of type point. Okay, so actually you can see this part that R.TL is this object. Okay, so it is an object of type 0,2. Similarly, R.BR is of type object. So basically, you are in some sense, you can say creating three objects here. One object of type rectangle, which contains two objects of type point. Okay, so yeah, so and then again, like we discussed, so the compiler will come up with a sort of a way to store this. Okay, and you need not think about that. Okay, so you can get the X of the TL object using this particular method, which is the dot operator, which is R.TL.X. Okay, I hope this is clear.
Sir?
Yes.
Sir, this point TL, we are defining an object. So, sir, if there were some functions in the point class, so means what would be then there?
Okay. So, see,
So basically my doubt is point TL, if we are defining point TL, so it is just having the variables of it. Can it have something more else than the variables of the class point?
Oh yes, of course. So if there was a, let's say you know, point, the class point had a function which is set point. Okay, so you could say here in the int main. Okay, and suppose that set point is also public. Okay, so you could say r.tl.setPoint, let's say 5,6. Okay, and the TL object of the rectangle R, okay, will now contain 5,6.
Yes, sir, got it, sir. And sir, means C++ don't have the static variable, static keyword, or it have?
It has static keyword. So anything that C has, C++ has. Yes. And we will come to what the static. So in the context of classes, what static means we will come to. So we will come to. But in the context of functions, static means exactly what it means in C. Okay, so it means that basically that variable is persisted across and across the across the program. Okay. Okay, so I think okay, I think this is clear. Okay, so okay, so now okay, so now what we are talking about definition of member functions here now. Okay, so obviously in C you cannot have any member functions. Okay, so you can have functions, something like, let's say, so for example, you can for a complex number you can compute the norm, or you can print the complex number. And in C you have to define a global function, something like a norm or a print, okay? And then you have to pass the particular object on which you want to call this function. So for example, you have that type complex and you have created an object of type complex, okay? But this does not have any member functions, okay? So when you say print, you have to say print C, okay? So then it'll pass the object to this print function, and inside this print function you can access the copy of the object. So in this case it's passing by value, so actually there will be a copy created inside the print function, okay, and you can access that, okay. Now here what is happening is that you see here norm is now a member function, and so is print, okay. So what does this do? So this basically says that you can invoke it as a member function like this, okay. So if you create also another object of type complex like this, okay, you can say C dot print, okay. Here you are passing C to print, here you are calling the member function of this particular object, okay. Now just to be clear, the member functions are all same, okay. For a simple class, if you forget inheritance for the timing, okay, so all objects of type complex will basically invoke the same member function print, okay. But remember that, so RE and IM will differ. So if you define two complex numbers here, C1 and C2, C1 dot print will actually call the same member function, okay, but its version of RE and IM will be different, okay. So it will be C1 dot RE and C1 dot IM, okay, whereas if I define another complex number which is C2, then it will be the other way around, okay. So yeah, okay. So now yeah, so again the same thing. So we are defining so this is so here look at I mean, one thing we discussed is that so we are defining these member functions. So notice that we are defining the member function inside the body of the class definition, okay. So this is one way of defining the member function. You can also define the member function outside the body of the class definition, okay. So in fact that is kind of preferred because what happens is if you define inside the body of the class definition, okay, it by default what C++ does is it assumes that these functions, so it adds the inline qualifier, if you remember the inline qualifier to all these member functions. So all calls, yeah, so basically the calls to the member function then become basically they are put in the code inline, okay. So it is actually recommended that for the substantial member functions you should actually define it outside, and we'll see how to define it outside the class definition, okay. Yes.
And so here in the void print function,
yes,
shouldn't we write like this dot RE and this dot IM?
So good. So yes, we can also do that. And yeah, so should we do that is a question we will come to, okay. So but this will also work, the just RE will also work, and this dot RE will also work. So this is the first answer, okay. Now when will this not work, okay. So suppose you defined a local variable inside the print function which is also by the name RE, okay. Then this particular method of accessing RE will not work. but this dot RE will work. Is it clear?
Yes, sir.
Okay, so
Sir, please repeat the previous sentence.
okay, so so this is you can think of it as a scoping rule. Okay, so this particular function is defined within the scope of the class definition, right? Okay, so RE is defined in this scope. Okay, I mean it will basically, so it is so there are two scopes, right? So there is this particular scope of the print function, and before that, just above that, there is the scope of the class definition. Okay, so because RE is not defined in the print function, okay, it is using the RE that is defined in the larger scope or the enclosing scope, which is this particular RE. But if there is a RE which is defined here inside the print function, then it will take that particular RE. Is it clear? So am I able to?
Yes, sir. Yes, sir.
So the name RE points to the RE which is defined in the most recent or the smallest scope. Okay. So that is what is taken by the compiler. Okay. Okay.
But sir, if there are two REs, one outside the class and another inside the class, so then can we differentiate them, both the REs by this pointer?
Yes. So by this pointer, if you say this dot RE, then it will always take the member variable. So this dot RE will always go to the member variable.
And if we directly write the RE, then which RE will it denote?
It will denote the local variable. Okay, the one which is within the scope. Okay, clear?
Sir, at that time, there will be both will be same. That if we write that this dot RE and only RE, then there will be no difference at that time.
No, if you define another RE variable inside the print function, then there are two variables.
Okay, sir. Yes, sir. Got it.
Okay. Okay. So now, yeah. Okay. So again, this is again another example using the rectangle. Okay, and you see you can have a compute area function which is in case of C it will be a global function, but in case of C++, you can have it as a member function, and then you see it becomes very, very intuitive. So you get a rectangle here. Okay, so you know what are the sides. So this is 5 minus 0 and 7 minus 2. So both it's a square actually, right? So you can just say R dot compute area and it will compute the area. Okay, so it becomes very, very intuitive when you are doing the programming. Okay, that this particular object R has an area. Okay, R is a rectangle, and you know R has an area, and you can just call R dot compute area to compute its area. Okay, so you know your thought process becomes like that. Okay, while writing the program.
Sir?
Yes.
So like suppose like there is a class, suppose in this case there is class pointer and it has int x and int y. Like suppose when I'm calling the class point, I don't want to define int x and int y, and I want to like change the value of I want to define the value of x inside a function inside class point. So while declaring the class point in main, can I like just send a like space or something? Like I don't want to define it at the start itself.
Yes. So you can define just rect R semicolon. Okay. that will basically define a variable of type R. It will create the memory, everything will be there, okay? Then you can just say R dot TL dot X is equal to 0, R dot TL dot Y is equal to 2, and so on and so forth, okay? Inside the main, you can do this. Because it is public, you can do it.
Yes, so like I can even define a function inside class point, for example, define X or something like.
Right, right. In fact, that is the better way of doing it, and we will come to that.
Okay.
Okay. So, okay. Okay. So yeah, again, example using stack, okay, and here you can see, progressively things are becoming more and more complex, right? Now for the stack, you have actually 4 member functions, okay? You have empty, which returns a boolean and checks whether it is empty or not, okay? You have top, which basically returns the data at the top, okay? I mean, but without popping that particular data, okay? So yeah, and you have push, which basically pushes a character into the stack, and you have pop, which just pops a character into the stack, okay? And you can see that you can very easily reverse a string, using the stack. I mean, again, you can just so you are defining the object of type stack, then you are setting its stop, you are creating you are creating its setting its stop to -1. So this is to have the state. Then you are defining a new string, which is str, and you are sort of initializing it to ABCDE, okay? And then what you are doing is, one by one, you are pushing str into the stack S, okay? And then you are trying to print the reverse string of this, okay? So you are basically running a while loop while checking whether the stack is empty or not. So while the stack is not empty, okay, you print s dot top, and then you pop one element from the stack, okay? This is how you proceed, okay? So you can see how that things are becoming simpler, okay? Okay. Any
Sir,
questions? Yes.
excuse me, sir. Sir, can we in the previous slide? Sir, can we here also do like int n in the stack itself, and then car data, and instead of 100 we say n.
You can do okay, can you do int n and then char data n? No, you cannot, right? Because int n is not initialized. But what you can do, so you can do that via constructor. So what you're trying to achieve is basically achieve a dynamic size stack, right? You can do that via constructor. We will come to that.
Yeah, okay, sir.
Okay. Okay. So okay. So yeah. So I think this is kind of clear. This is just this thing, and yeah. So so this is about the this pointer. Okay. It is an so like we discussed, it's an implicit pointer, holds the address of the object, okay? It serves as the identity of the object in C++, okay? Yeah, so the type of this pointer, so suppose you have an object of type X, okay, X is a class, okay, which is defining a type, okay. Then the so the type of this pointer of any object of class X, okay, is X star const this, okay. So this is important, that this pointer is constant. So you cannot say something like this is equal to something, okay. That will not work, okay. So you cannot change this pointer basically. Okay, so so again, and this pointer can be accessed only in methods. Okay, so yeah, so that is the other thing, that it is visible only inside the method. Okay. Okay. So now, yeah. So here is a basically here is a sort of example, small example showing that this pointer actually has the address of the object. Okay. So you have this member function f. Okay. So you have a class which has 2 integers, and then member function f, which basically sets the 2 integers, okay, and also prints this pointer, okay. So now if you define an object of type X here, and then you set the f value, okay, now you see it is printing the ID of the object, okay, which is, and then when you print the address of the object using ampersand a, you see that the 2 values are the same, okay. And moreover, you can print the components of this object, okay. So a.m1 and a.m2 are 2 and 3, okay. Okay. Yeah, so basically, now, I mean, just to give you a glimpse of, suppose, how, member functions are implemented, okay. Basically, what happens is, what you define is something like, so inside the class, void f int, something like this. So you define a member function f, which has a return type and some arguments, okay. In this case, actually, what gets defined is this void x : f, okay. This : is sort of a namespace qualification, okay. So like we told earlier, you see, this class X also defines a namespace, okay. So here, for the first time, you see that X is actually a namespace, because this function f is not a global function, it is in the namespace X, okay. And you can access this function by X : f, okay. And so this is one thing. So this is the name of the function now. So you can think of this as the global function is X : f, okay. Now this global function will also have the first argument, or yeah, so you can think of this, that this will be the first argument, which will actually have this pointer, okay. And the value of the current address, value of the address of the current object will be passed in this particular pointer, okay. And the other arguments will follow, okay. So a call like a.f, 23 is really X : f, ampersand a23, okay. Okay. Yeah. So yeah, so this we have discussed. You can distinguish a member from a non-member. So basically, yeah. So this arrow M2 definitely points to the member. Okay. In this case, it so happens that it also points to the M1 member. But as we have discussed, it can be that the case that if you don't use this, it is not guaranteed that that variable is a member variable. Okay. Okay. Yeah. And so the other thing is, see, in many cases, you will actually use this pointer. So here is one example where you will use this pointer. Okay. So suppose you are, having a doubly linked list. Okay. Where the node, each node is called is of type doubly linked node. Okay. And you are sort of doing an append. Okay. Okay, to a particular doubly linked node. Okay, and so then what you will do is basically you will say next is equal to x. Okay, so suppose you are at the last node of or you don't need to be let's say you are at the last node of this doubly linked list. Okay, and then you want to do an append. Okay, so what you will do is you will pass the other node to be appended. So this is another object of the same type, doubly linked node. Okay, and now so for the current object, you will just, so this is this arrow next basically, because it has a next pointer. Okay, so this arrow next will be equal to x, but also x's pref pointer should be this pointer, right? So should be this object. So you have to set x arrow pref is equal to this. Okay, so this is one explicit use where you are not only referencing this, but you are also actually using this as a R value in some sense. Yeah. Okay. So okay. Yeah. Yeah. So I think we have overshot by quite a while. We will continue. So we have a small thing to continue, state of an object, and then we will go into access specifiers and other things. Any questions? So,
Sir,
yes.
please stop the recording.
Okay. Yeah. So one thing is that I have uploaded a lot